up until now, equations, we've been able to do things like if you take a baseball and throw it in the air, you can do time in seconds, let's say, versus h, the height, and the ball would go up in the air and it would come back down. So you could record its height versus time. And if you threw a ball in the air, um, if you threw the ball in the air, you can also do its horizontal distance. So you might just do distance here. So there's some initial velocity on it. So basically the ball would kind of slow down. But until we put them both together, you only can do one at a time, vertical or horizontal distance. So what this now does, parametric, is allows us to put them into one equation. And so now you can do an x and a y. So you'll notice with parametric, there's an x and a y equation. And they're telling me t is going to go from -1 to 4. So we're going to take the t value and plug it into x. So negative of a -1 plus 2. So you end up with 3. And then you put in a 0. -0 is just 0, plus 2 is 2. And now when you put in a 1, you have -1 plus 2. So that's 1. And so you see this thing is behaving linear, constant rate of decay here. So 1, and then when you put a 2 in there, you get 0, and then -1 and -2. Now the same thing can happen with the t can go into the y equation. So -1 squared is 1, minus 4 is -3. 0 squared is 0, minus 4 is -4. 1 squared is 1, minus 4 is -3. 2 squared, 0. 3 squared is 9, minus 4 is 5. And 4 squared is 16, minus 4 is 12. So now we can go ahead and graph these, and it's the same graphing that we did before. So 3, -3 would be here. 2 to the right, down 4. 1 to the right, down 3. 0, 0. -1, 5. Oops, up one more. And -2, 12. So up, that would be about 12. So the graph goes something like this. And then anytime you do parametric equations, you want to make sure you're indicating the orientation or direction of these. And so we put arrows going along in the direction that the graph moved. And that's basically doing a parametric equation. So let's go ahead and do this one as a DIY. Go ahead and fill in the table, graph it, and indicate your direction. Pause the video now. So here's what the table would look like. Again, they gave us the x and the y equation. They're telling us what to do for t. So you would have had a point up here, and it came down along the y-axis, hits at 1, 0, bounces out this way, and you can see we indicated direction. So very important that you indicate direction. All right, now I'm going to walk you through the same problem on your calculator. So let's open up our calculator, and we're going into a totally new mode. So you have to scroll down and over. We're going to do, some calculators have PAR, but we're going to do a parametric mode. So hit enter. And now when you go over to y equals, the very first thing you notice is there's an x and a y equation. So that's how you know you're in parametric mode. And the first equation was 2 raised to the t. Now when you hit the variable button, it used to be x, now it's got the t. And the second equation was t squared. So if I go to my window, they told me to do -4, -4 to 4 for my x's by 1's fine. And our graph, something like -8 to 5 is probably fine. And, negative 5 to, negative 5, negative 1 is fine. It's going to go below that to a maximum of, let's say, 16. So when I hit graph, we can see the graph. I can adjust the window to be a little bit less on the negative here. So something like that. We can also look at the table to help us fill in the table. So go to table set. We can say start at negative 4 and just go by ones. And if I hit second graph, I can look at the table. So those are the numbers that we could do. So you see that the t went from negative 4 to 4. Now I know what my window should be. It should go from 0. We could go out to 16 if we wanted. It would be 16 high, but what we have is fine. But the one thing when you kept looking at the graph is that we don't know the direction. So one of the things that you can do when you graph these is make this t-step a little bit smaller. And the calculator has to make more calculations. Okay, and that's still pretty fast. So we can go ahead and even make it smaller, like 0.01. So now you can really see the direction and put your arrows on the graph. All right, so do example 3 as a DIY. Excuse me, you can do it by hand and fill in the table and do the graph by hand, or you can use your calculator to figure it out. Pause the video now. All right, so those would be the numbers that you use to fill in the table, and it's your basic, it's kind of a parabola graph here, so it goes down, comes back up on this side, and you put that, make sure you put the arrows on there to indicate direction. All right, there's a process called eliminating the parameter. So if you start in parametric mode, if you will, how can we put something into an equation that we would recognize from maybe our days in algebra? So that's going to what is called a rectangular equation, or something what people might call y equals mode, function mode. So you take a parametric equation, you solve one of them for t, you plug it into the other one, and then kind of clean up if you need to. So this first equation, I'm going to go ahead and add t to both sides, and then subtract x. That right there is going to go in for the y, and so now I have y equals 2 minus x quantity squared minus 4. And if you FOIL or box method 2 minus x, like do 2 minus x times 2 minus x, you get 4 minus 4x plus x squared minus 4. And those two things go away, and I have y equals x squared minus 4x, which is your parabola that looks something like that. Well, to be sure, we can go back and look at example number 1, or type this thing into our calculator and see what happens. So this is going back to example 1, and you notice that we have this parabola starting here because it would just continue up through here, something like this. So now I know that my parametric equation, when I turn it into rectangular mode, should yield a parabola. All right, do example number 5 as a DIY. So pause the video now. So if we take this first one and we just add the 2 to the other side, I get t is equal to x plus 2. Substitute that in over here, so I have to distribute the 6 to the x, 6 to the 2. And when I clean it up, it's linear. Y equals 6x minus 3. So we're going to go ahead and graph this on our calculator and see that we get something with slope 6, intercept -3, just to make sure. So if I go into y equals and we clear this out, the first equation was t minus 2, and the second equation is 6t minus 15. And let's go ahead and do a zoom 6, which is just a standard window. And you can see it's -3 for the intercept, up 1, 2, 3, 4, 5, 6 over 1. So it's matching the slope. So I feel pretty good about our answer. Okay, so if you look at these parametric equations, the first thing you'll notice is that there's no t, and they've switched to trig functions within the equations. So they could still have a t here, but anytime you see trig functions, we want to isolate that trig function, so we're going to subtract 3. Oh, forgot my 5. Now divide by 5. And so I have x minus 3 over 5. Over here, for the y, I'm going to add the 4 to the other side and then divide by 5. So you end up with y plus 4 over 5 is equal to the sine of theta. Now, there's one equation out there that introduces sine and cosine, but no other trig function. And that's basically our cosine squared plus sine squared is equal to 1, that number one Pythagorean identity. What this allows me to do is I'm going to take this and plug it in for cosine. So that will be x minus 3 over 5 squared. And we're going to do y plus 4 over 5 squared is equal to 1. So doing a little cleanup, I'm just going to leave it x minus 3 on top over 25. And y plus 4 squared over 25 is equal to 1. Now this is starting to look like an ellipse, except that both denominators are 25, and that can't be true for an ellipse. So if I multiply both sides by 25, or all terms by 25, I end up with x minus 3 quantity squared plus y plus 4 quantity squared is equal to 25. And now when you look at that, that's a circle to the right 3, down 4 with the radius of 5. So let's go ahead and go to our calculator and make sure that that's what it is. So I'm going to clear these equations out. Now the first one is 5 cosine. Now we don't want to find theta, put a theta in there, this green thing here. We want the button. We're still going to put t in there because we're in parametric mode. And then the y value is 5 sine minus 4. So the thing that we're going to do here is we're going to go into mode, and my calculator is in degree mode. So if I want to go around the unit circle, I'm going to do 0 to 360 by about 7.5. Even 10 degrees is probably enough. And so when you look at this graph, there it is. Now we can also hit zoom square, which is number 5, and now it cleans the screen up for us and makes the distances, each tick mark is exactly the same. So to the right 3, down 4, there's my center with radius of 5. So again, I feel pretty good about this being my answer when I eliminated the parameter. So you're going to try number 7 on your own and see what you come up with. Pause the video now. So on this one, if we subtract the 2 and divide by 3, add the 4, divide by 5, put that in for cosine squared, put this in for sine squared. Just leave the top as the top squared. Now you have 9 over 25. So you have this ellipse. And you can type that into your graphing calculator to make sure you're getting what would be an ellipse shifted to the right 2, down 4, little skinny 3 to the side, 5 up and down. When you deal with y equals mode or function mode, there's only one graph for every equation. So this thing, I'll draw it over here. This would be vertex form, so it's left 3, up 4, the vertex. And remember, that negative sign right there means it goes down. So something to that effect, some parabola going down. So if I go in and they say when x is t, so remember for parametric, you need two things. You need an x equation, okay, I already know x is t. And then if I substitute that in, my y would be negative t plus 3 squared plus 4. So when I go to the calculator, it should give me the upside down parabola. So we put t there, and I go negative t plus 3 quantity squared plus 4. All right, so I need to go to my window, and let's just make this, because we don't know, make it negative 10 to 10. Oops. Negative 10 by 1. So upside down parabola. And if you need to see the direction, remember you can slow it down. Do the next two as DIYs, come up with the two equations, and let's see what you get. Should be the same parabola. You can check it on your calculator. Pause the video now. So this one you already are given your x equals t minus 3. That goes in here, and if you clean it up a bit, you can type these two into your calculator. And here, x is t divided by 3, so when you put that in for x, this is what it would look like for your y value. So there's, again, a set of x and y equations to put in. And so the weird thing is, there are all these different parametric equations that yield the same graph. Okay, let's do number 9 as a DIY. Again, we know that this graph is a U-shaped graph opening down, shifted up 1. So you're going to say t is x, come up with the y equation by plugging it in. And then here you have to solve for x and plug that in. And then you'll have your y equation. So then take a look at it. So pause it now, come back and check the answer. So this one, it says t is x, so x equals t. You plug it in, t goes right in there for the x, and your y equation now is 1 minus t squared. So when you graph that one, it is the upside down parabola. Notice the direction, up on the left side, down on the right. This one, if I solve for x, I get x is 1 minus t, so that's my x equation. Now, if x is 1 minus t, I'm going to plug that in here. So again, if you type these two in, you can kind of clean up that parabola after you put the 1 minus t in there, and you clean it up. These are your two equations. And the only difference really is you have the same U-shaped graph, but this one goes up to the right, down to the left. And if you fill in the two tables, the tables are right here. So things are just in a different order, but you graph them and you get the same graph. Okay, so on this last one, it's back to parametric equations with some trig stuff in it. So we're going to isolate the trig function. Just divide by the 4. And again, there's a t there, but because it's trig function, we don't want to solve for t. And over here, we're just going to divide by 4. So I have y divided by 4 is equal to the sine of t. And cosine squared plus sine squared is equal to 1. Now, this is already cosine squared. So when I put this in there, I just put it in as x over 4. Whereas this one is sine of t, so when I put this one in, it's the y over 4, but then I have to square it. So now you have x over 4 plus y squared over 16. And now I'm going to multiply every term by 16 to get rid of the fractions. So this is 4x, this is y squared, and this is 16. So we're dealing with a parabola. So I have y squared equals, we're going to move this to this side. So negative 4x plus 16. And remember with the parabola, we want to factor out that negative 4. And 16 divided by negative 4 is negative 4. So there's my equation. Now I know this from what we did in 9.1 to 9.3. My x is 4. And there's, plus 0 here. So there's my vertex. Because y is squared and the 4p thing is negative, I know my parabola. I shouldn't put an arrow tip on there. I know my parabola is going to the left. So let's go ahead and go back to our calculator and type this in to make sure that this is going left. So 4. Now, I need to put a parentheses to type this in. So I'm going to do cosine of t, but I square that. So that's the only way. You can't put the squared after the cosine. It has to be everything squared. And then the sine is 4 sine of t. And again, we're doing around the unit circle. So I'm in degree mode, so I want to go 0 to 360. 1 should be good enough. Let's go ahead and graph it. And you can see the parabola does that. Now, if you want the parabola to extend, we could go, well, that's fine. Let's just leave it like that. So you can see the sideways parabola.